Hello students, let us discuss the shapes of molecules containing both bond pair and lone pair. As we have already discussed VSEPR theory in the previous video. So in that we have discussed that the shapes of some of the molecules. But in some molecules like ammonia, the geometry which we have discussed here, it is tetrahedral, but the shape is pyramidal because of the presence of a lone pair. Here, due to the presence of a lone pair, as we have discussed here, lone pair and bond pair repulsion is greater than bond pair repulsion. Because of this reason, the repulsion which is obtained, the repulsion which is observed by bond pair is lesser. So, and this repulsion is greater, that is lone pair bond pair repulsion is greater. So, the bond will be due to the repulsion of lone pair, the bond pair will be moved inward. So, the angle get reduced from 109.5 degree, the angle get reduced to 107 degree because of the greater repulsion between the lone pair bond pair than the bond pair. So in simple words we can say that its angle is not 109.5 degree as we are expecting for the case of tetrahedral geometry. Its angle is reduced to 107 degree because of the greater lone pair bond pair repulsion than the bond pair repulsion. In water, the angle which we are expecting because of tetrahedral geometry, that is 109.5 degree, but actually the angle is 104.5 degree because here there are two lone pairs. Because of the two lone pairs, here lone pair repulsion takes place, which is greater than, that is lone pair bond pair repulsion, and which is greater than bond pair repulsion. So because of the two lone pairs, the bond pairs will be moved inward. So the angle get reduced from 109.5 degree to 104.5 degree. Thus, the angle is reduced due to the presence of two lone pairs. So just now we have done for ammonia. In the case of ammonia, the angle is reduced to 107 degree. That is because in ammonia there is only one lone pair. So here there is only lone pair and bond pair repulsion and bond pair repulsion. But in the case of water, there are two lone pairs, therefore lone pair repulsion also takes place, lone pair bond pair repulsion and bond pair repulsion. So because of the greater lone pair repulsion, the angle get reduced to 104.5 degree. Let us take the next case, that is SF4. SF4, the total number of bond pairs, that is 1, 2, 3, 4. 4 bond pairs, and there are only a single lone pair. That is, here on the sulfur there is a single lone pair. So total number of pair is 5. So the geometry is trigonal bipyramid. Now, the case here where we need to keep a lone pair, because here out of 5 terminal position, 1, 2, 3, 4, 5, there are 5 terminal position. From this 5 terminal position, from where need to keep the lone pair? That is the question arises, where we need to keep the lone pair. Either on the equatorial position or on the axial position. This position, that is above the plane and below the plane, this position is called as axial position, and the position like that is on the same plane, that is these positions are called as equatorial position. So here 3 equatorial position and 2 axial positions are there. So actually where the lone pair will takes, either the equatorial or the axial. So in this because only single lone pair is there. So lone pair bond pair repulsion is there and bond pair repulsion is there. Because the lone pair bond pair repulsion is greater, so because of this reason the lone pair will try to occupy such a position where that it get maximum angle. So if it is on this position, that is on the axial position, in that case the angle will be 90 degree with the plane. Here the angle is 90 degree with the plane. That means the lone pair is occupying 90 degree with the plane. But in this case, the lone pair and the other bond pair occupy 1 degree angle. So where is the maximum angle here? That is in the case of this position. So that is the most right position where the lone pair occupy. That position, it will occupy the position that is the equatorial position, not the axial position. So whenever we are making a structure that is a trigonal bipyramidal structure, and if there is a presence of lone pair, you always keep the lone pair in the equatorial position, not in the axial position, because here the angle is 120 degree angle. So maximum distance, minimum will be the repulsion. So that is the shape for this molecule. That is actually, this shape is called as seesaw. Seesaw because it is looks like a seesaw. That is, the shape is seesaw, and this is the most stable form, the structure or the shape for this molecule. Next, in the case of ClF3, the bond pairs, 3 bond pair and 2 lone pairs. So total number 3 bond pair plus 2 lone pair, that is equal to 5. So from 5 total pairs are there. So what will be the geometry? The geometry will be trigonal bipyramid. Now again here comes where need to keep the lone pair. So here in the first structure, that is here, where the lone pair is kept, it is on the equatorial position. 2 lone pairs are on the equatorial position. Now in the second structure, you can see that one lone pair is on the axial position, one is on the equatorial position, and in this structure both the lone pair is on the axial position. So which is the most stable? That is this one. That is, the first structure is the correct structure, because in this structure the lone pair is occupying the position, that is equatorial position, where it occupy an angle of 120 degree angle. But here one of the lone pair is occupying 90 degree angle, and here both are occupying 90 degree angle. So where is the maximum angle? The maximum angle here, it is 120 degree angle. So the maximum angle it occupies, so that minimum will be the repulsion. So this is the most stable form of the structure of ClF3. Now what will be the shape for this molecule? Because after removing the 2 lone pair, what is the shape of this one? Look at here. It look like a T. So what is the shape for this molecule? That is, its shape is like T. So its shape is T shape. That is after the removing of lone pair. So we can say that its shape is T shape. So these are the some examples in which the lone pair is present with the bond pair. So in that case we need to keep how we have to keep the lone pair in which position, that we have discussed here. So this is all about this video. Have a nice day.